As the James Webb Telescope just observed artificial light on the planet Proxima b, the JWST MIRI instrument is capable of detecting large artificial light sources on distant planets. This is the first real evidence of a technosignature of probably intelligent life forms on another planet. MIRI is a high-resolution infrared instrument that is extremely sensitive to infrared radiation and can therefore detect distant metropolitan cities and industrial facilities at any time. This applies not only to our neighboring system Proxima Centauri. MIRI can detect artificial light sources and potential alien cities throughout the known universe. It sounds fantastic what we can do with our new super telescopes on Earth or from near-Earth space. We can now easily detect large settlements within the known universe. We have already achieved a masterpiece with the MIRI spectrometer at the JWST, and there is even more to come. Another mega telescope will be launched in Chile in 2028. The extremely large telescope, YELT, will once again outshine everything that has come before. With a 39mm main mirror, this telescope will look deeper and sharper into space than ever before. We need these technical innovations because our thirst for knowledge about the universe is far from quenched. We are only at the beginning of exploring distant worlds, and we need instruments like the JWST and the YELT to examine exoplanets for traces of life. In addition to the ability to detect artificial light emanating from gigantic cities in space or extraterrestrial airfields, we will soon be using a new secret weapon with the AER system. We will be able to detect traces of vegetation on distant planets. The development will go on and on in our search for other species in space. We will use more and better instruments and tools until we have found and made contact with other life forms. The first artificial light source on Proxima b. Scientists have long dreamed of this. For the first time, they are using a telescope to look so precisely into our neighboring star system that places of life become visible to us. An artificial light source on the planet Proxima b reveals the presence of technology, and therefore also of some form of advanced life. It sounds crazy, but the JWST could even analyze our own activities on Earth based on our light signatures. The best telescopes of all time would easily capture the lights of major cities such as New York, Rio de Janeiro, or Beijing. With its fine sensors, it can filter out the artificial light traces of airports, large industrial plants, or even space stations from the natural light emissions of the Earth. The same is happening on Proxima b. For the first time, we will have precise analyses in our hands of where life is located there, how much artificial light it produces, and how mechanized this species is likely to be. We have thus made a quantum leap in our search for life in space, and one day we will certainly have the technical means to communicate with other civilizations. If we wanted to send messages to Proxima b, they would take more than 4 years to travel one way by normal means. We would have to wait another 4 years for a reply to come back. All hopes are currently pinned on the development of the first quantum computers. Quanta know neither a fixed place nor a fixed time. Once we have cracked this fantastic technology, we will develop quantum means of communication and communicate with distant civilizations as if in real time. Does that sound like pure utopia to you? Then hold on tight because utopias often become truths very quickly. Simulation of the surface of Proxima b. It was 2016 and a long way from the now very real era of James Webb, when scientists dreamed of exploring alien worlds. Back then, a groundbreaking simulation predicted how the James Webb Space Telescope would study the surface of the exoplanet Proxima b in an unknown future. These simulations aim to analyze the planet's atmospheric and thermal properties. And of course, by 2016, researchers were already dreaming of finding out whether Proxima b had an atmosphere that was potentially hospitable to life. What was utopia less than 10 years ago is now reality. At that time, simulations of Proxima b's unique orbit already showed that the highly interesting exoplanet lies within the habitable zone of its parent star Proxima Centauri. The JWST will carry out regular and comprehensive observations of the day and night sides of Proxima b. This planet orbits its star in a bound manner, just as our moon orbits us. Proxima b always has the same side facing its star, and one side is always in shadow. Reconstructions have shown that there must be extreme temperature differences between the day and night sides of Proxima b unless the planet has an atmosphere that redistributes heat. Without an atmosphere, the day side would be blazing hot, and the night side icy cold. The presence of an atmosphere, on the other hand, would allow heat to be distributed more evenly, and this is exactly what we can now find out thanks to the JWST. The 2016 simulations showed even more. There could be a temperate strip in the border areas between the day and night sides. It sounds strange to imagine that civilizations exist on a planet that is half light and half dark, and that these beings settle on a strip that is perhaps several thousand km wide around the globe. But it is possible. We need to keep opening our horizons and possibilities in the search for other life forms in space. To be really sure, we need real analysis. In 2016, the exact analyses of the chemical composition of the atmosphere of Proxima b were still a dream. Today, the JWST proves its ingenuity every day and shows us exact analysis profiles for worlds that are sometimes hundreds or even thousands of light-years away. The JWST can recognize signatures of water, carbon dioxide, and methane, and has already made a find. The last comprehensive profile was obtained from the exoplanet K2-18b, where the JWST found evidence of 4 biomarkers in the atmosphere. The more such biosignatures are measured around a planet, the more likely it is that life could exist there. Particularly exciting is the potential discovery of ozone, which is considered a strong indicator of biological activity because it is predominantly produced by biological processes in our atmosphere. K2-18b could therefore be an inhabited world. However, we have not yet found any traces of artificial light there. This planet could be a pure water world, but that does not mean that it is uninhabited. We have to take into account that there is intelligent life in the water, possibly even cities, and we have to consider that not all developed species have artificial light. We haven't had the light bulb for that long, and yet humans were already intelligent and to a certain extent mechanized in ancient times. The JWST detects plant growth on Proxima b. The James Webb Space Telescope, or JWST, is primarily designed to observe the universe in the infrared range and carry out detailed spectral analyses of distant celestial bodies. What the JWST has not yet proven is its ability to detect plant growth on exoplanets, but it does have the potential to do this. In our search for life in space, we must not only rely on technosignatures and the emissions of highly advanced species, we must also look for planets that may only have plants and animals or other simpler life forms. The JWST can provide indirect evidence of plant growth by analyzing atmospheric constituents and reflected light spectra. Scientists call this technique vegetation red edge, or VRE for short. These are spectral signatures created by the reflective properties of plants in the near-infrared range. When light passes through the atmosphere of an exoplanet and is reflected by the surface, specific patterns in the reflected light could indicate the presence of chlorophyll or photosynthetic pigments. The detection of such signatures is still very challenging. The detection of VRE requires extremely precise measurements and high resolution, which can be affected by the exoplanet's atmospheric disturbances and the signal-to-noise ratio. Although the JWST is designed for such measurements, we are now beginning to utilize these capabilities, and researchers are certainly getting better at finding and detecting traces of life in space. We are living in exciting times because the JWST has started a revolution in space exploration, and this development continues. Direct detection of plant growth or biological activity will require future telescopes and missions specifically designed to search for biosignatures. One example is the planned Webb Telescope. LUVOIR stands for Large Ultraviolet Optical Infrared Surveyor, and this future space telescope aims, among other things, to examine the atmospheric properties of exoplanets with even greater precision and to detect potential biosignatures, such as the VRE spectral lines. LUVOIR will be able to isolate and analyze the light from exoplanets even better than the JWST. It will be able to cover a larger number of wavelength ranges and thus perform more detailed spectral analyses, which are necessary to detect plant or biological activity. Of course, The vegetation red edge measurements will also be able to detect possible plant growth on Proxima b and vegetation there. What did the extremely large telescope find on Proxima b? Perhaps you are now wondering how the extremely large telescope could have examined the planet Proxima b, if it is currently still being built in the Atacama Desert in Chile. The answer to this question is quite simple. Here too, researchers have created a simulation to show long before the launch how the YELTI will scan the sky. With its impressive 39 primary mirror, the YELTI will be the largest optical and near-infrared telescope in the world, and it will finally go into operation in 2028. The YELTI has been specifically designed to analyze the atmospheric and surface properties of exoplanets. With its high resolution and light sensitivity, the YELTI can detect extremely faint signals from distant planets, similar to the JWST. By using adaptive optics, this new telescope can also correct atmospheric distort.